Hello friends, welcome to my lecture on conditional probability. So far we considered the probabilities without any condition or without prior knowledge of the occurrence of other events. Therefore, we call them unconditional probabilities. Now we shall consider the probabilities of events or simple events when the knowledge of the occurrence of some other event or simple events is available. If we want to find the probability of A given that B has happened, it means that we want the frequency of A and B happening together relative to the frequency of the event V happening. That is, we want to find PAB divided by PB. We denote this conditional probability by PA given B and read as probability of A given B. For example, the probability that any given person has a cough on any given day may be only 5%, but if we know or assume that the person has a cold, then he or she is much more likely to be coughing. The conditional probability of coughing given that you have a cold might be a much higher 75%. Probability of A given B may or may not be equal to PA. PA is the unconditional probability of A. If PA over B equal to PA, then events A and B are called independent. In such a case, having knowledge about either event does not change our knowledge about the other event. Also in general, the probability of A given B, the conditional probability of A given B is not equal to the probability of B given A. Okay. So, let us now go to the formal definition. Let A and B be any two events. The conditional probability of A given B denoted by PA by B is given by PA by B equal to PAB divided by PB. Now, since A intersection B is a subset of B, so probability of A intersection B is less than or equal to probability of B, because we have already shown that if A is subset of B, then probability of A is less than or equal to probability of B. So, 0 is less than or equal to P intersection B less than or equal to PB, and therefore, PAB divided by PB is less than or equal to 1. So, the 0 is less than or equal to probability of A given B less than or equal to 1. Now, for example, consider the simple case of a die. Okay. Suppose a fair die is tossed and it is known that it showed a number greater than 3. We wish to find the probability that the number is 4. So, let us denote the event the die shows 4 by A and the event the die shows a number greater than 3, okay, by B. Then A is equal to the singleton set 4 and B is equal to the set consisting of 4, 5 and 6, because B is the event that the number is greater than 3. Okay. So, B is equal to 4, 5, 6. Now, therefore, probability of A is equal to 1 by 6, while probability of B is 1 by 2, because there are 3 elements here 4, 5, 6, though the probability of B will be 3 by 6. So, 1 by 2. Now, probability of A given B is probability of AB divided by PB. Okay, probability of AB. Now, A is 4, B is 4, 5, 6. So, A intersection B is the set consisting of 4 only, and the probability of just 4 is 1 by 6. So, probability of AB is 1 by 6 divided by probability of B is half, and therefore, the probability that the number is 4 given that the number shows is greater than 3 will be equal to 1 by 3. Now, let us do some questions on conditional probability. Suppose the ratio of male and female students in a college is 3:1. Okay. So, probability of a male student is equal to 3 by 4. Probability of a female student will be 1 by 4. Now, the probability that the probability is 4 that a male student will take part in sports activities. Okay. So, probability that the male student takes part in sport activities. So, sports and the student is male. Okay. This is equal to 1 by 4, while the same probability, the corresponding probability for a female student is 1 by 10. Okay. Now, what is the probability that a student selected at random will be a male sports student? Okay. So, probability the student is male and sports is and plays sports, okay, male and sports. So, this will be equal to, by multiplication theorem we know that probability of A intersection B is equal to P A into P B by A. Okay. So, P probability of male into probability that sports male. Okay. So, this will be equal to probability of male student is 3 by 4, probability that the male student takes parts in the sports activities is 1 by 4. So, the probability is 3 by 16. So, this is part A. In part B, a student selected at random will be one who takes parts in sports activities. Okay. So, probability of a student takes part in sports. Okay. Now, this will be equal to probability. Now, this student could be a male as well as a female. So, probability of male into probability of sports given that he is a male plus probability of female into probability of sports given that it is a female. So, this is probability of male, this is 3 by 4 into this one is 1 by 4, probability of male student, probability that the male student takes parts in sport activities. So, 1 by 4 plus probability that the student is a female 1 by 4 into the female student takes part in sports activities, that is 1 by 10. Okay. So, this is 3 by 60, the 3 by 16 plus 1 by 40. Okay. So, let me find how much it is, 3 by 16 plus 1 by 40. So, LCM will be 80. Okay. So, 16 5 ja 80. So, 5 3 ja 15 plus 2. Okay. So, 17 by 80. Okay. Now, third part is a sports student selected at random will be a male student. So, we are given that the student who has been selected is a sports student, okay, but we want the probability that the student is a male. Okay. So, we have this probability, we have to find probability of a male given that he takes parts in sports activities. Okay. So, this is probability that a student takes parts in sports activities. A student plays sports, and then probability of male and plays sports. Okay. So, probability of male and plays sport divided probability student plays sports. So, this part we have already just now found, it is probability that a student plays sports is 17 by 80. Okay. And probability that the student is a male and plays sports is probability of being a male into probability that sports given that it is a male. Okay. So, this is probability of A intersection B. Okay. Probability, this is probability of A intersection B is probability of A into probability of B given A. So, probability of A male, probability of male student is 3 by 4, and then probability of sports given that male 1 by 4. Okay. So, 3 by 4 into 1 by 4 divided by 17 by 80. So, this is 3 by 16 into 80 by 17, and what we get 15 by 5 ja. Okay, so 16 5 ja 80. So, we have 15 divided by 17. Okay. So, this is the probability of that a student selected student is sports student, a sports student is selected and it is the male student. Now, we go to second question. A committee is composed of 70% executives. So, probability of an executive is 0.7, probability of a worker is 0.3. Okay. If the member of the committee is executive, the probability is 0.7. Okay. If the member is worker, probability is 0.3. Okay. It is known that 40% of the executives and 50% of the workers favor a pending issue. So, probability favor a pending issue. Given that the member is executive, okay, is equal to 0.40. Okay. Probability that okay, it is given that 40% of the executives and 50% of the workers favor a pending issue. So, probability that the member which is executive favors a pending issue is 0.40, and probability that the worker is a member and member is member is a worker and it favors a pending issue is 0.50. What is the probability that a committee member is a worker given that he favors the issue? So, probability of member favors the issue. Okay, a committee member favors the issue. That member could be executive as well as a worker. So, probability of executive into probability of favors the issue given that it is executive, okay, plus probability that the member is a worker into favors the issue given that it is a worker. Okay. So, this will be equal to 0.7 into favors the issue 0.4 plus probability it is a worker 0.3 into favors the issue 0.5. So, this is 0.28 plus 0.15 means 0.43. Okay. Now, we are given that the member favors the issue, we have to find that the probability that the member is a worker. Okay. So, probability that the member is a worker given that favors the issue. Okay. So, this is equal to probability of W into probability that he favors the issue and is a worker, divided by probability that the member favors the issue. Member favors the issue. Okay. So, PW is equal to 0.3, P favors the issue and is a worker given that it is a worker 0.5. Okay. So, what we have? This will be equal to, so this is equal to PW is 0.3 into 0.5 divided by 0.43. So, this is 15 by 43. 0.15 divided by 0.43 is 15 by 43. So, the answer is 14 by 43, 15 by 43. Now, a box of 100 gaskets contains 10 gaskets with type A defects. Okay. So, probability of gasket having A defect is equal to 10 by 100 means 0.1. Okay. Probability of a gasket having B defect is equal to 5 by 100 means 1 by 20. Probability of a gasket having both sides of defect. Okay. So, probability both the defects. Probability of a gasket having both the defects A and B is equal to 2 by 100, 0.02. Okay. Now, find the probability that a gasket to be drawn has a type B defect under the condition that it has a type A defect. Okay. So, it is given that we have to find the probability that the type B defect given that it has a type A defect. So, by conditional probability we need to get the probability that the gasket should have type B defect, intersection type A defect. So, and type A defect, both the defects divided by the probability that it has type A defect. Okay. So, probability that gasket has both A and B defect is 2 by 100. Okay. So, 0.02 divided by it has type A defect means 0.1. Okay. So, we have 2 by 10. Okay. So, this is equal to 0.2, that is 20%. Okay. So, the probability is 0.2 or 1 by 5. Okay. Now, a box contains 4 bad and 6 good tubes. 2 are drawn out from the box at a time. One of them is tested and is found to be good. What is the probability that the other one is also good? Okay. So, let A denote the event that the first tube is good. Then P A equal to 6 are good. Okay. 6 are good. So, we have 6 by 10 or we can say 3 by 5. Okay. And then let B denote the event that the second one is also good. Okay. Then probability of B given A, okay, B given A is equal to probability of A intersection B intersection A we can say divided by P A. Okay. Now, P B intersection A is what? 10 C 2 divided by 6 C 2 divided by 10 C 2. Okay, divided by 3 by 5. Okay. We draw 2 tubes from the box, okay, which are both good. Okay. So, 6 C 2 divided by 10 C 2 will be the probability. So, 6 C 2 is 6 into 5 by 2, that is 15, divided by 10 into 9 by 2, that is 45. Okay. So, this is 15. Okay. 6 C 2 is 15 and this is 10 C 2 is 45 divided by 3 by 5. So, how much is this? This is 1 by 3. Okay. So, we have 5 by 9. Okay. So, this is the answer. Now, if P A equal to 0.5, P B equal to 0.3, P A intersection B 0.15, then we want to find P A intersection B dash. P give A given B dash. That means we want the probability of P A intersection B dash divided by P B dash. P A intersection B dash is P A minus B divided by P B dash is 1 minus P B. P A minus B is equal to P A minus P A intersection B divided by 1 minus P B. P A is equal to 0.5, P A intersection B is 0.15 divided by 1 minus P B is 1 minus 0.3. So, this is 0.35 divided by 0.70 means it is half. Okay. So, we get this probability. Okay. Now, we go to sixth question. A manufacturer of airplane parts knows that the probability is 0.8 that an order will be ready for shipment on time. So, let A denote the event that the shipment will be ready on time. Then P A is equal to 0.8. Okay. Let us denote B by the event that it will be delivered on time. Okay. Let B denote the event that the order will be delivered on time. Will be delivered on time. Okay. So, then what we want, what is the probability? 0.7 is the probability that an order will be ready for shipment and will be delivered on time. Okay. So, P A intersection B is given, P A intersection B is equal to 0.7. Okay. What is the probability that such an order will be delivered on time given that it was ready for shipment? Okay. So, probability of we want probability of B, okay, probability of B given A. So, this will be equal to probability of B intersection A divided by probability of A. So, this is 0.7 divided by 0.8. So, this is 7 by 8. Now, 3 groups of children contain 3 girls and 1 boy, 2 girls and 2 boys and 1 girl and 3 boys. So, let us say group 1, group 2, group 3. Here there are 3 girls and 1 boy. Okay, G means girl, B means boy, 2 girls and 2 boys, and here 1 girl and 3 boys. Okay. 1 child is selected at random from each group, so that the chance that the 3 selected consist of 1 girl and 2 boys. Okay. So, we want 1 girl and 2 boys. Okay. So, 1 girl and 2 boys we want. So, how many possible combinations are there from group 1? Okay. Girl from group 1. So, I will write in the order. Okay. So, if we girl from group 1, boy from group 2 and boy from group 3, this is one combination. Then boy from group 1, girl from group 2 and then boy from group 3, this is second combination. Third can be boy from group 1, boy from group 2 and girl from group 3. Okay. Now, having a girl from group 1 is so the probability of having a girl from group 1 is 3 by 4, having a boy from group 2 is 2 by 4, having a boy from group 3 is 3 by 4. Here having a boy from group 1 is 1 by 4, having a girl from group 2 is 2 by 4, having a boy from group 3 is 3 by 4, and here having a boy from group 1 is 1 by 4, having a boy from group 2 is 2 by 4, having a girl from group 3 is 1 by 4. Okay. So, this is how much this is we can cancel out. So, this is 2 here. So, this will be 9 by 32. Here what we will get? So, 3 by 32, and how much here we get? 1 by 32. Okay. So, there are 3 possibilities, 1, 2, 3. Okay. So, probability of having a girl and 2 boys is equal to 9 by 32 plus 3 by 32 plus 1 by 32 means 13 by 32, and we get the answer. Okay. Now, we go to this question, or the odds that a book will be reviewed favorably by 3 independent critics are 5 to 1, 4 to 2 and 2 to 4. Okay. So, probability that the review will be in favor, okay, is 5 to 1, means 5 by 6. Okay. So, favorable report by reviewer 1 has the probability 5 by 6. Probability of a favorable report by reviewer 2, by reviewer 2. Okay. So, I am taking the same thing, favorable report by reviewer 2. So, this is 4 to 2, that means 4 by 6, and similarly probability of a favorable report by reviewer 3. Is equal to 2 by 6. Okay. Now, what is the probability that of the 3 reviews, okay, a majority will be favorable? So, probability that 2 reviews are favorable, let us first find this probability that 2 reviews are favorable. So, this is, let us say this is favorable, this is favorable, and this is not favorable. So, 5 by 6 into 4 by 6, this is not favorable. So, this will be, this is 1 by 3. Okay. So, this means 2 by 3. Okay. So, this is favorable, this is favorable, this is not favorable, plus now this is favorable 5 by 6, this is not favorable, this is 2 by 3. So, this is not favorable means 1 by 3, and this is favorable means 1 by 3. Then suppose this is not favorable. So, 1 by 6, this is favorable 2 by 3, and this also 1 by 3, this is 1 by 3. Okay. So, we have so this is 2 by 3. Okay. So, this is 54. Okay. 54, 5 to the 10 to the 20, this is 5 here, okay, this is 2 here. We have here 2 to the 4, 4, 5 to 20, then we have here 5, here we have, so this is 27. Okay. Then all 3 give the favorable report, all reviews are favorable. So, this will be equal to 5 by 6 plus 2 by 3, 1 by 3. So, this will be equal to 54, no, not 54, we have 6, we are adding, no, we have to multiply 5 by 6, 2 by 3, 1 by 3. So, we have 5 to the 10 by 54. Okay. So, either this or this. Okay. If it happens, we will the majority will be favorable. Okay. So, required probability is equal to 27 by 54 plus 10 by 54, which gives us 37 by 54. So, this answer. Okay. Now, if the probability that a communication system has high selectivity is 0.72. Okay. So, high selectivity this is 0.72, and the probability that it will have high fidelity this is 0.63, and the probability that it will have both. Okay. So, let us say this is A event A, this is B, then probability of A intersection B is equal to 0.23. Okay. Now, find the probability that a system with high selectivity will have high fidelity. So, probability of high fidelity given that it has high selectivity. So, this means that we want the probability of B given A, which is equal to probability of B intersection A divided by probability of A. So, this is equal to 0.23 divided by probability of A, that is 0.72, and we get 23 by 72. Okay. Now, if A and B are independent events such that probability of A is 2 by 3, probability of A union B is 3 by 4, let us find probability of B. Okay. So, probability of A dash intersection B dash. Okay. Probability of A dash intersection B dash is what? Probability of A union B complement. Okay. This is equal to 1 minus probability of A union B, and this is 1 minus 3 by 4. So, we get 1 by 4. We have got the probability of A dash intersection B dash. Now, probability of we are given the probability of A. Okay. Probability of A is 2 by 3. Okay. Probability of A union B, okay, is 3 by 4. Now, probability of A intersection B. Okay. We need to have the probability of, we have found the probability of A dash intersection B dash. A and B are independent events. So, A dash and B dash are also independent events. Okay. So, probability of A dash intersection B dash, okay, is equal to P A dash intersection P B dash. Okay. It can be shown that if A and B are independent events, then A dash and B dash are also independent events. So, probability of A dash intersection B dash is P A dash intersection P B dash into P B dash. So, that is P A dash means 1 minus P A into 1 minus P B. Okay. So, what we will get here, probability of A dash intersection B dash is 1 by 4, 1 by 4 equal to 1 minus we need to find P B. Okay. So, 1 by 4 equal to 1 minus 2 by 3 into 1 minus P B, this is 1 by 3 into 1 minus P B, and this gives you what? 1 minus P B equal to 3 by 4, 3 by 4. So, P B equal to 1 by 4. Okay. So, we get this 1 by 4. Now, A is known to hit the target in 2 out of 3 shots. Okay. So, probability of A hitting the target, this is equal to 2 by 3. Probability of B hitting the target, it is 3 by 5. Okay. What is the probability of the target being hit when both of them try? Okay. So, target will be hit if one of the two hits the target. Okay. So, probability of the target is hit. Okay. The probability that the target is hit is equal to 1 minus probability that no one hits the target. Okay. So, that will give you 2 by 3 means A does not hit the target, it is 1 by 3, and B does not hit the target is 2 by 5. So, 1 by 3 into 2 by 5. So, this is 13 by 15. Okay. Now, we go to this question, let A and B be two independent events. So, P A intersection B is equal to P A intersection P B. Okay, P A intersection B is equal to P A into P B, because A and B are independent events, such that the probability that neither of them will occur, P A dash intersection B dash, neither A occurs nor B occurs, is equal to 1 by 3. Okay. And both of them occur simultaneously means A intersection B, probability of A intersection B is 1 by 6. Okay. We have to find P A and P B. Okay. P A dash intersection B dash gives you probability of A union B dash, okay, which is equal to 1 minus P A union B. Okay. So, P A dash intersection B dash is equal to 1 by 3. So, 1 by 3 equal to 1 minus P A intersection B. So, this gives you P A intersection B equal to 2 by 3. P A union B, sorry. Okay. P A union B equal to 2 by 3. Now, P A union B is equal to P A plus P B minus P A intersection B. Okay. P A union B is 2 by 3, 2 by 3 equal to P A plus P B minus P A intersection B is 1 by 6. Okay. So, this gives you P A plus P B equal to 2 by 3 plus 1 by 6. So, this will be 4 by 6 plus 1 by 6 means 5 by 6. Okay. Now, we know the value of P A plus P B, and we also know the value of P A intersection B, that is P A P B. Okay. From that we can easily find the values of P A and P B. So, let us see, we can do this. P A plus P B equal to 5 by 6. Okay. P A into P B. Okay. This is P A into P B equal to 1 by 6. So, this is equal to 1 by. So, now P A minus P B whole square equal to P A plus P B whole square minus 4 P A P B. Okay. So, this will be equal to 25 by 36, okay, 5 by 6 whole square minus this will be 4 by 6, okay, 4 into 1 by 6, 4 by 6, 4 by 6. Okay. So, this will be equal to 25 minus 24. So, 1 by 36. Okay. So, this gives you P A minus P B equal to plus minus 1 by 6. Okay. So, we know the value of P A plus P B and P A minus P B. Okay. So, taking positive sign, P A plus P B is equal to 5 by 6, P A minus P B equal to 1 by 6. Okay, we are taking positive sign here. This gives you 2 P A. You can add these equations. So, we get 5 by 6, 1 by 6, that means 6 by 6. So, that is 1. So, P A equal to half. Okay. P A equal to half and P B will be equal to 5 by 6 minus half. So, we get 5 by 6 minus 3 by 6. So, this means 2 by 6 means 1 by 3. Okay. So, P A equal to 1 by 2, P B equal to 1 by 3. If you take negative sign, taking negative sign, we get P A plus P B equal to 5 by 6 and P A minus P B equal to minus 1 by 6. So, what we do, we again add, this give you 2 P A equal to 5 by 6 minus 1 by 6. So, 4 by 6. Okay. So, this means 2 by 3. Okay. This gives you P A equal to 1 by 3. And when P A is 1 by 3, P B will be equal to 5 by 6 minus 1 by 3. Okay. This means 2 by 6. So, 3 by 6 means 1 by 2. Okay. So, the answers are 1 by 2, 1 by 3, 1 by 3, 1 by 2. Okay. With that, I would like to end my lecture. Thank you very much for your attention.